So we're going to, well, welcome back everybody, first of all. So what we're going to do today is we are going to talk about what happens to the quadratic parent function when we add some things to it, okay? And so first of all, we need to see what the quadratic parent function is, okay? And that is f of x is equal to x squared. That is the quadratic parent function, okay? If you were to graph the quadratic parent function, it would look something like this. Okay, let me get this pulled up right here. Quadratic parent function is just x squared, and it is the basic parabola right there. Notice that the vertex is at the origin. It is at 0, 0, and it is considered, that vertex is considered a minimum. Pull this up and make this a little bit smaller here. I'll graph this. I'll sketch that on the other graph here in just a second. The graph opens upward, or we could say it is positive. It's a positive parabola. It is positive, it opens upward. Okay, and so it looks something like this. Okay, that's what it looks like. Okay, that is the parent function. Okay, so once we start adding some things to it, things start happening to it. Okay, it moves around, it transforms. That's what a transformation is. Things change. Okay, and so what we're going to do is we're going to graph each one of these and see what happens to them. Okay, so we're going to graph y equals 2x squared. We're going to graph y equals 1/3 x squared. We're going to graph y equals negative 4x squared, and we're going to graph y equals negative 0.5 x squared. I don't know if you can barely see that 0.5, but we're going to graph those, okay? All right, so I'm going to pull my graph page up here just a second. I had to pause that. Okay, so what I want to do is I want to graph these, okay? So let me get another document, another graph page, and I want to graph 2x squared. 2x squared, graph that, and this is what it looks like, okay? So it looks like, oh gosh. Oh, well, it doesn't look like that, does it? All right. Graph that one. What I'm gonna do is, to save some time, I'm gonna come back and sketch that. I'm gonna add another graph. I'm gonna do control divide 1/3 x squared. And I'm going to come back here in just a second. I'm going to pause the video and I'm going to sketch these and reveal those so that the video is just not running and you're watching me sketch these. Okay. All right. And then I need to graph negative 4x squared. Control doc, add graphs, negative 4x squared. So that's what it looks like, right? I'm going to add another page. Let's see. I have a negative 0.5 x squared, okay? All right, and that's what it looks like. So I'm going to go back, I'm going to pause the video, and I'm going to run back over here, and I'm going to graph each one of these. I'm going to sketch each one of these on the graph, okay? All right, I'll be right back. And while I'm doing that, I want you to do the same. I want you to graph those on your calculator, and I want you to go back, and I want you to sketch them, and then we'll meet back up, okay? All right, see you in a sec. Well, it's a good thing I didn't make you wait through all that because it took me forever. Okay, so all I did was graph a couple of those points. So I can graph the origin, which, by the way, answers this first question. It never moved. It stayed at the origin. Every one of them stayed at the origin. So we can answer this first question. It says, what do you notice about the vertex of each parabola? All right, it's always at the origin for these, okay? Now the origin is at 0, 0, right? You do know that. Okay. So it was always at the origin. And then, so what happened each time something changed, it made it wider, made it skinnier, had a couple that were up and a couple that were down, okay? So The next question says, how does A, or what we put in for A, so we had a 2, we had a 1/3, we had a -4, we had a -0.5. How does A affect whether the graph opens up or down? Well, if you notice, whenever it is a positive, the graph opens up. And if it's negative, the graph opens down. Okay. And then the shape of the graph. Okay. So if you notice, anytime it is a fractional number or a number, I'm going to say if it's a number between 0 and 1, let's just do a number between 0 and 1, the graph is wider. Okay. And then if the number is greater than 1, then the graph is narrower or skinnier. Skinny. We're just going to call it skinny. Okay. All right. So there is A. Okay. Now we're going to move on and see what happens when we change B. If we apply B to each parabola, what happens to that? Okay. All right. So I'm starting to get a bunch of graphs here. I'm just going to start a whole new document. Okay. So I'm going to add a graph page, but now notice B is inside of these parentheses, okay? And I'm going to graph this just like it says. I'm going to graph each one of these. I'm going to pause the video, come back after I have graphed them, and sketch them on there. I want you to do the same thing, okay? You know, because it takes a little bit of time. All right, so you do that, and I'm going to be doing the same thing, okay? All right. This time, I want you to see if you can answer some of these questions down here. I'm going to go ahead and answer this one right here. And then, you know what, answer all of those. See what you come up with. And then we will talk about them. I'm going to answer all of them, and we will talk about them whenever we come back. Okay? All right. Okay. So after you graph these, when you graph them, okay, so the first one was y equals 2x inside parentheses squared, okay? And so what it does, it makes it real narrow, doesn't it? Okay, and then negative 0.3x, all of that squared. Ooh, look how wide it gets. And then 1/2 x, that squared, that's pretty wide too. And then if you notice negative 4x squared, all of that is squared, and so it's pretty narrow, isn't it? Okay, so the questions ask, what do you notice about the vertex of each parabola? And I typed this out so you could see it a little bit better. So if you notice that the vertex still is at the origin. The origin is hasn't moved. The vertex hasn't moved. It's still at the origin. And now B, they want to know, does it affect whether the graph opens up or down? And so the answer to that is no, it doesn't affect whether it opens up or down. And the reason why is because you have to remember that anything that's squared is still positive. So if you think about negative times a negative, it's still a positive. If it's squared, it's multiplied times itself, right? Okay, so it's still positive, so it's still a positive graph. All right, and then so how does B affect the shape of the graph? It's very similar to what A would do. And so if B is greater than 1, it makes it narrower. If B is in between 0 and 1, it makes it wider. Okay? All right. So let's try these right here. Same thing. What I want you to do is I want you to graph these. So this is the third transformation is what happens if you add or subtract a number behind the x squared. There's no parentheses now. It's just what happens if you add or subtract a number. All right, so what I want you to do is I want you to graph these in your calculator, and then and then sketch them on the graphs, and then answer these 4 questions down here, and we will come back and talk about them. Okay? All right, see you in a sec. Okay, so I've graphed these in the calculator and sketched them on the graph. Answered these few questions. And so let's see how y'all did. All right, so if you notice when you graph them, they kind of move around, don't they? All right, so the first one, x squared plus 3, notice where it moved. X squared minus 1, it moved where? X squared plus 1 moved where? And x squared minus 3 moved where? Okay. All right, so what do you notice about the vertex of each parabola? So the vertex is no longer still at the origin. What happens to it? It moves up or down the y-axis based on D. Right, let me add that, up or down the y-axis based on what D is, right? If it's a positive, it moves up. If it's a negative, it moves down. So how does D affect whether the graph opens up or down? Well, you know what? D really doesn't affect that, right? It only affects it moving up or down. And so, because we added a positive and a negative, and it only made it move up or down. And then the shape stays exactly the same. All it's doing is moving up and down the y-axis. Okay, so we have one more transformation, and that is C. And I want you to see where it is. Did you get that? Okay, it's on the inside of the parentheses. Okay, so I want you to watch this one. Okay, I want you to graph these, and then I want you to watch and see what happens with those. Graph them and answer these questions down here, and I will be back. I'm going to do the same thing. Let's see how you do. Okay. All right. See you in a sec. Okay. So, if you graph each one of those, you'll notice that these graphs move left and right depending on what goes in for C. So the questions, whenever you answer the questions, the first one, the vertex moves left or right depending on the value of C. If C is positive, it moves left. If C is negative, it moves right. C doesn't affect whether the graph opens up or down. It still opens up. It doesn't make it move down. And then the shape is still the same. Okay. So if we're going to recap, to save some time on the video, I'm just going to summarize the effects of A, B, C, and D on the function f of x. And so I'm going to do that and then come right back. I'm going to pause the video and then bring those back to you, okay? Hang on just a moment. Okay, and as a quick recap, when f of x is changed to a times the f of x, makes the graph wide or narrow, and it changes the opening from opening up or opening down. If it's positive, it opens up. If it is negative, it opens down. When f of x is changed to f with the b inside b times x, makes the graph wide or narrow. If the c moves the function left or right, and d moves the function up or down. Okay, so we're going to recap that, and we're going to practice that in our next video. So be ready, because you're going to have to put that into motion. All right, see you in a sec.